All right, guys, welcome in. Today I'm going to be gone, obviously, like I told you guys yesterday in class. And so we're going to work on some of the similar stuff we've been doing with our equations, looking at solving using our balanced moves, right? Making sure that our order is important, right? Our opposite operations are important, our values are important, all of those things we've been talking about in class the last few days, okay? So you're going to take these notes and go through and answer the questions and fill in the blanks with me here, and then you'll work on your IXL assignment. So we want to make sure that we think about, the goal and what we've been working on, what we've seen the last few days in class with our lessons. And the goal is to be able to solve an equation in which variables appear on both sides. So we have multiple steps, we have multiple pieces, multiple values, different opposite operations, that we need to answer in order to help us solve these questions. And so we're going to see different things that pop up, right? So remember, there's many different ways to solve equations with one variable. Just in general, we want to make sure that moves get us closer to an equation like variable equals the number, right? Okay, so we're trying to isolate that variable x equals, or y equals, or t equals, whatever it ends up being. So we're always looking for a solution, right, for that unknown value. So like, for example, down here, we're trying to get to t equals something, right? Whatever our answer would be for that one, or we could get to a equals something for this one, okay? So if we have an equation like this where it says 3t plus 5 equals 7, right? We know that we have to do multiple steps, opposite operations, in order to get or isolate, right, that variable by itself. So the idea is to work through and answer the questions, right, in order to get t by itself. So we know that if we were looking at this, the first thing we'd want to do, right, to isolate that variable is get rid of this plus 5. So subtracting 5 from each side, taking that away, right, would eliminate it here, and it would leave us with an equation that looks like this. We still have 3t on one side, and that's equal to, since this is a balanced move, and we're subtracting 5 from each side, 7 minus 5 would equal 2, okay? And so we're trying to get to our answer of what t would equal, that missing piece. So our second step, in order to look at this two-step equation here, would be to divide each side of the equation by 3, because this is a multiplication problem, right? 3 times t equals 2. And that would leave t by itself. So we have to do the opposite operation, divide by 3. We're going to get a fraction answer, but that's fine, right? We don't necessarily have to have a whole number answer. It doesn't always have to be positive when we get our final answer here. But in order to solve this equation, if we'd want 3 times something plus 5 to equal 7, we know that it'd have to be 2 plus 5 equals 7. And so 3 times 2/3, or if t is 2/3, that would be our answer for that, okay? If we take a look at this second equation over here, right, we have something like this where it's 4 times the quantity of a minus 5. So remember, we saw parentheses, we automatically usually think, right, that we want to distribute here, okay? But we also can look at both sides of the equal sign and try to determine if there's other steps, right, different ways, right, to solve an equation. And so in this case, if I look at this, this is a multiplication step, right? It's 4 times whatever's in the parentheses, which is a minus 5. But if I look at the number that's factored here that I'm multiplying, and I look at the other value on the other side, we could actually do a step of division here. So if I divide each side by 4, that's going to leave us with, if I take that division problem, right, to eliminate the multiplication step here, and I divide 12 by 4, right, that's going to leave us with fewer factors on the left. That's going to leave us with less pieces. So if I divide by 4, all I'm left with is that a minus 5, because that was what I was going to multiply by 4. And then that's equal to 3. So that's a different step, right? We've been used to, and what we've always been told, the last 2 or 3 years in math, if we see parentheses, we want to multiply or distribute. We could also think of it in terms of a division step, since that is multiplication, right? It's multiplying whatever's on the outside but whatever's on the inside. If I look at both sides of the equal sign and I say, well, I've got a value over here, right? A term in just 12 by itself, a constant term that's also divisible by 4. So a step I could actually do there would be to divide by 4. I could have distributed and then tried to solve it as a two-step equation from there, but I can also look at this and say, how could I make this smaller in terms of the number of factors? So I could also make it a division step. Okay, and then we get down to one-step equation because I want to know what a equals, so I have to get rid of this plus 5. So like it says, I'm going to add 5 to each side, and that would leave a by itself because a negative 5 plus 5 eliminates. If I add 5 to 3, now I'm left with a equals 8. So that's another way I could get that answer, okay? Okay, so now I'm thinking, it says people use the following steps to solve linear equations in one variable, right? So when you think about this, there's one variable here, whether they're on one side or the other. We go back to our BCMS steps. This went way back before Thanksgiving break. We did kind of our equations boot camp type stuff. I'm actually going to put the picture of what BCMS stands for again in the Schoology folder today so you guys can see it on the slide. But remember, that meant B, which was begin with parentheses. So anytime that you can see parentheses, you want to solve that way. C stood for combined, or in this case, they say collect like terms, okay? M meant move the variable, right? So move the parts with the variable to the one side because we want to isolate it. And then S was the solving step. So very similar, right, in what they say here in these 5 steps. So the first thing a lot of us do, right, is we begin with parentheses. So we use the distributive property, right? Which, remember, that means multiply. So I'll make a note of that right here too. When we use the distributive property, multiply so that all expressions no longer have parentheses. We want to get rid of that, right? So we use that distributive property to get rid of those parentheses. Then what we do is we collect like terms, right? Those are the terms with the same variable or no variable at all, right? So things like 3x minus 6x would be like terms, or 6 plus 22, right? Those are like terms. If they're on the same side, we would combine those, right? Terms with the same variable or terms without a variable, constant numbers. Those are your like terms, all right? And then third part here, it says add or subtract an expression so that there's a variable on just one side of the equation, right? We want to isolate. This is that step where we isolate the variable, right? We talk about getting that on just one side, okay? And then we get down to our solving steps, and our solving steps a lot of times are just our basic 4 operations. It says add or subtract expressions so that there's just a variable, or sorry, just a normal number on the other side, or a constant, right? Just a number on the other side. Remember, a constant is just a number by itself, okay? And then usually the last step is to either multiply, or a lot of times it's divide, right, by a number, so you have an equation that looks like a variable equals a number. So x equals -6, or y equals 15, or even t equals 2/3. We saw that up there in those examples. So those BCMS steps that we went way back over, before Thanksgiving break, like I said, I'll put that screenshot of that slide in the folder again today. But again, these 5 steps are kind of saying things. We start with parentheses, so we distribute. Okay, so we no longer have those parentheses or those things that are grouped. Then we collect or combine our like terms on each side of the equation. We usually add or subtract an expression, so there's a variable just on one side, right? So if we had variables on both sides, we can move all of our x terms to one side, and then we get our constant numbers to the other side, right? And then a lot of times our last step is to either multiply or divide by a number, so we can get that equation that looks like x equals y equals t equals whatever our variable ends up being. So following these steps will always work, but they may not always be the most efficient method. From lots of experience, we learn how to use different approaches, right? So there's more than one way to solve these equations. That's what it comes down to when we think about it here, okay? So I'm going to go through, there's 3 different things that I can see to answer this summary question here at the end. Again, different ways to go about solving the problem. Order matters, but you have to choose it correctly based on your values, right? So let me give you my first example in blue of what I could do, okay? So I'm looking at this equation, right? If I draw a line down the equation here, the equal sign, if 9 minus 2b plus 6 is supposed to be equal to -3 times the quantity, we're multiplying what's in parentheses here, times the quantity of b plus 5 plus 4b, there's multiple ways that I could go about trying to solve this, okay? And a lot of it has to do with opposite operations, right? In terms of thinking how to solve it, combining like terms, right? Looking for that, trying to get to isolate the variable on one side, looking for a constant or normal number on the other side. There's a lot of different ways we could do this. So I'm going to focus my energy on the left-hand side of the equation first. What could I do first over here to make it simpler to try to solve this equation to eventually get to b equals something? Well, what I look at right here is I have a +9 and a +6. Already on the left-hand side of the equation, those are like terms. So I could go ahead and combine a 9 and 6, right, and simplify that part of the equation. Since these are like terms, I can go ahead and combine those. This is just addition and subtraction steps. 2b is multiplication, but again, 2b is a term, 2 times b. That's not a like term with 9 and 6. So I'm not going to worry about combining those, but I could go ahead and take a 9 and a 6 and add those together on this side of the equation, okay? The second thing that I'm going to look at, right, since I can't really do anything on the left, is come over here to the right-hand side and automatically say I've got a -3 value that I know I could distribute, right, to whatever's on the inside of those parentheses. So I could go ahead and distribute, which we know, we've talked about the last few days in class too, means multiply -3 times that b plus 5 in parentheses, right? I could do that step, okay? And then there's one other thing that I think I can do, right? And I'm actually going to jump back to the left-hand side of the equation to think about this. I know that this is a -2b, and I actually have a positive 4b before I do any sort of multiplication here, right? I know I'm going to get another b term between this -3 times b, but before I even did that parentheses, since there's multiple terms on both sides, I could go ahead and try to simplify this by saying, okay, what could I do, or how could I move that 2b, that -2b minus 2b over here with that 4b? So my third step I could actually do would be to add 2b to both sides, okay? I could actually do that step even before the distributive property. That way I would get rid of it over here, right? If I added the 2b over here, I could add 2b over there. And so then what I'd be left with if I did this step would be 15, because the 9 and the 6 we talked about, right? We could do that, is equal to, and then I could keep everything the same to start, still have that parentheses with distributive property, but then also say, okay, a 4b plus 2b would be like adding 6b's. So again, multiple ways about going and trying to solve these equations and answer these questions. So there's a lot that goes into this, guys, as you're answering these questions. And what I'll tell you is, you know, we've done this the last few days in class. There's no one right or wrong way to start the equation, but the best thing you can think about is keeping all of this stuff in mind that we've talked about, right? The order being important, the values being important, and making sure you're using those opposite operations correctly. So in your IXL assignment, you've got different types of equations, multi-step equations that you're trying to solve and answer. So what you need to do is honestly take what we've done the last few days and apply it, right? Use a piece of paper, use the whiteboard tables, whatever you need to, but take your time to write out your steps and answer the questions that way, okay? So hopefully these notes and these examples kind of helped out. Make sure that you fill this out and you kind of keep this in front of you as you go. You can flip over on the back of this note sheet because it's blank and do your work that way for the IXL. Make sure you get a SMART score of 80. That's what you're shooting for, right? And then if you have to go back and finish any sort of practice problems or things like that, make sure you're doing that too if you got some extra time today. All right, I will be back in class tomorrow. So if you have questions about this, we'll kind of go a little bit further, a little bit more in depth with it on Wednesday's lesson 2. But we'll kind of just keep building off what we've been doing. All right. Thanks for taking the time to watch this video and filling this out. Make sure you get your IXL done before the end of the hour. That way you don't have any homework tonight.